Okay, so we are looking at the warm-up question from kinematics, the particle motion. So the given function is the position function, okay? T cube is actually here. So this is the position. It doesn't matter what the graph is. You're giving the function, right? So in order to differentiate, we have to use the power rule, and then when you differentiate, you get the velocity function. So, okay, I just want to show you this first. So we differentiate, find the velocity function, and I ask you to graph it. Why? Because when you graph the velocity function, we are able to see the positive or negative sign. You have to graph it. This is quadratic. We can factor and find zeros, right? -2, -4, so the zeros at 2 and the 4. Quadratic, leading coefficient positive, open up or down? Up, so cross that 2 and the 4. So it's positive, negative, positive. Very easy, right? Once you know the velocity sign, velocity positive, particle move to which direction? You're moving to the right. And then you're moving to the left. Because velocity negative, moving to the right. So at 2 and 4, velocity is 0. That means this is happen to be changing direction. Because you're moving to the right and then turn to left. And then you're moving to the left and you turn to right. So because the sign of velocity changes, that's when you change directions. So velocity is 0 at these 2 points, and the sign changes. So at this 2 point, right, you change its direction. Okay, change direction. It's not necessarily velocity is 0, particle is changing direction, because if I have a velocity function look like this, velocity, positive, 0, positive, see that? If this is 3 and this is, say, 10. At t equals 3, is the particle changing direction? Well, look at the sign. Moving positive, right? I'm moving to the right, and I stop. Velocity is 0, and then continue to move to the right. I'm just stopping, and then I move to the right again. So although velocity is 0 at this point, you're not changing direction because the sign doesn't change. See that? Only when t equals 10, particle is changing direction, because it originally moved to the right, now you move to the left. So sign has to change for particle to change direction. Okay, now you differentiate to find acceleration, and also find the 0 at 3. And this is the positive slope, or something like that, right? This is the acceleration. Okay, so we can answer the questions from the sheets now. So I will post this for you, don't worry. First, what is the particle's initial position? Initial means t equals to 0. At the beginning, where is the particle? Substitute 0 into position. So S of 0 is 4. Start at 4 centimeter spot. And then what is the initial velocity? Initial velocity, you have to find the derivative of position. Substitute 0 into velocity. So it's 24 centimeters per second. You must have the unit if they provide the unit. Right here. Position in centimeter, t in second. So that's done. Now find the velocity acceleration. We did that. We graph it. Okay, so graphing this immediately show us the particle's motion. Is particle moving to the right or left? That all depends on which function? velocity. You just need to look at the velocity. Doesn't have anything to do with the position. All right, if you're in position at negative 100, you can still move to the right, right? So only look at the velocity for direction. Positive means you're moving to the right. Negative means you're moving to the left and the right. So C, find the time interval when the particle is moving to the right. Okay, so see the positive part here? So on the interval from 0 to 2, also 4 to infinity, isn't it positive velocity? The particle is moving to the right. This is not a complete answer. You need to justify. Why do you say this interval moving to the right? Because velocity is positive in these intervals. Just provide the sign diagram or graph is not a sufficient answer to justify. Why? Because are you asking me to interpret this sign myself? I'm not doing that, right? You should. So this is just a reference for you. And you need to say, oh, velocity is positive, so moving to the right. Raise your hand if you understand how to write a complete answer. Good. When is the particle moving to the left? Negative velocity. So 2 to 4. In this interval, particle moves to the left. Justify? Because velocity is negative. Okay, in the previous lessons, I said use the endpoint, closed interval. I'm going to change that. So I checked the textbook. Actually, they use the open interval. So we're gonna open, right? The endpoint is when velocity is 0. That's the moment of changing direction. So let's not include that. However, do you see the moving to the right? I did include the 0 because we found the initial velocity, right? It's already positive. So that's why I'm including that. Positive velocity is moving to the right. Okay, so close, open, open, open. Yeah. When is the particle changing direction? Okay, your first candidate should be setting V is 0. Those are the possible time particle change direction. So when V is 0, we have 2 times. T equals to 2 and a 4. So we say when T equals to 2 and 4, particle is changing direction because velocity is 0. If you stop here, you still don't get the full credit. Like I said, velocity is 0 doesn't mean you're changing direction. What else do you need to say? Changes signs. Velocity changes signs. The sign of velocity changes. If this is negative, negative, that means I'm just moving to the left and I stop to drink some tea and I continue to move to the left. I'm not turning around, right? Only when I change the sign, I will be changing direction. So remember that. When is the particle speeding up? Speed up, slow down. We have to look at velocity and acceleration because you know your direction. You need to know is the acceleration is the same as the direction you're going, right? Is the force with you or against you? So it's a package deal. You can't just look at acceleration alone. So, oh, positive acceleration, so you're speeding up. Not true, not true. So that's why we create the sign for acceleration. Okay, the boundary point is 3. 0 to 3, velocity, acceleration is negative. After 3, positive. If you're moving to the right, positive velocity, but the force is opposite, trying to push you back to the other direction, you will slow down. If you're moving to the left, the force is with you, pushing you to the left, then you will speed up in that direction. So we are looking at the same sign, positive, positive, negative, negative. So we know if the particle is speeding up. So by looking at this, from 2 to 3, 4 to infinity, these two time interval, the particle is actually speeding up. Justified. How do you justify? Because velocity and acceleration have the same sign. Okay, there's negative, negative in this interval, positive, positive. Right? Same thing, right? You know how to justify particles slow down in the other interval because velocity and acceleration has opposite signs. So particle motion. All right, this question is giving you the function equation. You have to figure the graph out. Question 1 is actually provide the graph of position function, and you have to figure out the velocity. Okay, so I will post this. Go home and do it without looking at the answer. See if you can get it. All right, we squeeze the 80-minute class to 45 minutes, so we have to get going. Last time we did the derivative of trig. Remember that? You have to memorize the derivative of 6 trig functions, derivative of sine, cosine, tangent, cotangent, secant, cosecant. Alright, develop a system so you can memorize this. Well, at least remember those 3. Yeah. Derivative of, okay, everybody, let's memorize this one. Derivative of sine is, derivative of cosine is negative sine. Derivative of tangent is secant square. Alright? Now, can we associate the, after that, derivative of the secant? Since derivative of tan is secant square, then the secant is secant and tangent. So they are actually associated. Next, derivative of cotangent. Cotangent, secant already associated with tangent, so the other part is cosecant, and then it's negative, then there's a co, right? Anything but a cosine, cosecant, cotangent are all negative. Negative 1, secant squared. And the last part is, last one is, what is derivative of cosecant? Cosecant is, derivative of that is secant times cotan. Alright? You just have to memorize this. I'm sorry. Okay, that's kind of basics. Now, with this, we can combine all the function and mix up to ask you to find the derivative. We might create the product of 2 functions where you need to apply product rule. U times V. What's the derivative of U times V? Judy?
U times V dash plus V dash. I mean, U dash times V.
Yeah, very good. So, this is U, right? U times V prime plus V times U prime, and you add them together. All right. In this quiz, we probably won't ask you to solve for derivative is equal to 0, so you can just keep it like this without doing anything else, okay? But in the future, if we say, can you solve for x when the derivative is 0, then you will have to factor in the factor form. Why? Because when you set this equal to 0, I can say either that is 0 or that is 0 to solve. Okay, here is the example of product rule. Yes? top is quadratic divided by cosine, so cosine square in the denominator. So this is a b square, right? U divided by b whole b high minus high b whole over whole. Okay? So I will post the solution once again. You do all the practice you need to. Okay. Let's see, this is the suspended weight that you put it down. This is your lowest. And you start from 5 meters from the ceiling, right? The position of this weight, what is S of 0? What is cosine 0? 1. So it's 5. That means at the beginning, I put this down right here, I hold it, and then ready, set, go, release, up and down. So you start from highest point. Find the velocity at time t. And we need to differentiate s of t, so s prime of t. Janice, can you help me to differentiate that? What do you think? Negative sine t is the derivative of cosine. What do you do with the fact? No. Are you doing product rule? This, yeah, this is just a coefficient, right? 5 times cosine. So when we differentiate, keep the coefficient and differentiate that. So it should be 5 times negative sine t. So it just negative 5 sine t. Can I use product rule? Yes, I can use product rule, but it's just a little bit complicated. This is much easier. So Ethan, find acceleration function. So differentiate.
So we first find the derivative of sine, which is cosine, and then so it's negative 5 cosine.
Very good. That's it. Okay? Differentiate that. Alright, next. I'm gonna skip this. This is just to show you how to use the difference quotient. Definition of derivative to find the derivative of sine. Okay, we did explore the derivative of sine using the graph, the slope. But for anybody interested why derivative of sine is cosine, you can go through this. This is the sine sum of angle, the trig formula you learn from honors pre-calc. So, okay, sine of a plus b is sine a cosine b plus whatever that is. And then, remember we have those limits. So I'm going to factor the sine out of the 2 parts here. And then you left the cosine minus 1 over h. Okay? Separate the 2 terms. Okay, here, this part. Limit when h equal to 0 of cosine minus 1 is 0. So this is 0. 0 times anything is 0. And the other part. Sine x over x when x equal to 0 is 1. See, that's the same. So the limit is 1. So this is 0. This is cosine 0 times 1, which is cosine x times 1. Anyway, if you're interested, there are more here to show you why. Okay. We already did this, so I won't go through this again, okay? This is exactly the same as the warm-up question. So you find the derivative, create the sine diagram, so you can answer, is the particle moving to the right, to the left, at rest, speed up, slowing down. Oh, okay, since I already give you this graph, let's just look at the answer. When is the particle at rest? It's when v equal to 0. So t equals to 2 and 3 seconds because velocity is 0. Okay, because they are only as at rest, so that is good enough. If they say when is the particle changing direction, then you will have to say what? Velocity is 0 and the sign changes at those times. Moving to the left, look at the negative velocity. Okay, why is the particle moving to the left? Velocity is negative. Finally, slowing down. Can you tell from the sign? Signs are different. Which interval?
Yeah, 0 to 2.
0 to 2.
5.5 to 3.
Yeah, 2.5 to 3. Good. It's difficult to see like this because A and B have different interval. So usually I will create the same interval to help me see better. Okay? So it's a positive, negative, 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 positive, positive, positive. Okay.
This is just like the question we did, right?
Yes, exactly. So I just want to show in this interval, the particle is slowing down because package deal, right? Look at both B and A, they have the opposite sign. That's why the particle slow down. Okay. More. This is trying to find the derivative of cotangent. Use quotient rule. All right. So that's that. All right, this is product rule. Who remember what's the derivative of secant?
That's like secant times.
Secant times tangent, yes. What's the derivative of cosecant? Positive or negative? Negative. Cosecant. Cotangent. All right, you will get there. I trust you. Trust you. And then don't forget, this is product rule. U times V. So UV prime plus VU prime. Okay. Am I going too fast? Sorry. I record this so you can go back to watch it again if it's too fast. So this question, right, this is the y is this function. Wow, complicated. But we know the derivative of every single part. And we know this is a quotient of two functions. So we have no problem to differentiate that, right? It says, can you find the slope of line of tangent to the curve? Where? At this point, at x equals to pi. X equals to pi. So our first step is to find the derivative, okay? Using what rule? Quotient rule. So let's go. Ho ho. There we go. Oh, derivative of the x is 1 minus ID over O. Okay, can I ask you please do not try to simplify, expand, and do not do any of that. What you should do is substitute x equal to pi right there. That will make things a lot easier. So we want to find the slope of tangent. So it's the value of the slope. That's why we can sub in pi for every single x. And then you can evaluate. Now, what is sine pi? 0. Right here, pi is 0. This point is 0, 1, negative 1. What is cosine pi? Negative 1. Sine pi is 0, right? There we go. Pi and pi cancel. 1. Okay, negative 1. All right, close. So, what did I do? Pi minus pi. Oh, yes, this is negative times negative, so that is negative pi times negative 1, so it's pi. The numerator becomes pi, the denominator is 0, right? Pi squared. So after you simplify, this is the slope of tangent, 1 over pi.
Is it like you do 1 minus 1 first, so it's 0. So the 0 times negative pi, so it's 0.
等一下，说再说一次。
是 cosine pi 不是negative 1。
Cosine pi is negative 1, yes.
那 negative 1
Yes,
plus
yes,
one,
yes,
so
可以
zero.
可以可以可以，对对对对对对对，很好。所以这个是 zero， 所以这个就是 zero， 不用看了，对不对？然后这边是 zero， 所以就是一个 pi。
Oh, okay. No, I
Yeah, so
got
it's
you.
pi. Yeah, I'm looking at the other. I did expand and then cancel the pi. 都可以，都可以。Either way is fine. Okay, so there is something wrong on this solution. Can somebody tell me what is going on? The notation is not good. If you write this, I'm gonna duck 0.5 for notation. Can you tell? Nobody? Happening? Can you tell? What's wrong with this?
Should you do like f dash x and x equals?
No. What is the function? Function is y. It's not f of x. Why do you change the name of the function? So Aaron, what's your last name? Liu. Okay. Can I call you Wang Xiansen? I can't, right? I can't just change somebody's name. Function is the same. Y equals 2, that's y equals 2. So I should take away all that. That's not right. What should I do here? Y prime. Or if you like dy dx, that's fine too. Can I just do y prime is this and then equal? That's another point off. Oh my god. These are not the same, right? This is a function in terms of x. This is what? A value of slope. They're not together. They're not the same. So what should you do? Y prime, have a bar and have a note when x equals to pi. Yes?
Can you do like y prime and then parentheses like I?
Yeah, but this is better. That's fine. I can accept that. Or you want to write dy dx when x equals to pi. That is good too. Perfect. So do not make the notation mistake. Okay? Right. Now this is it. So we finished the version of the trig. Today we do want to go over chain rule. So can you take out your calculator, please? We need to explore. Take out your calculator.